Hello GCC, Chem 130 students. This is the second video from chapter 12. Now we're going to do some math. So get out your calculator. We're going to do some calculations now that we know what a mole is. So the mole can be written as a conversion factor, meaning we can put it in parentheses with a line through it and something on top and something on bottom. We can put 6.02 times 10 to the 23rd atoms over 1 mole. It could be molecules. Doesn't have to be atoms. Or we can write 1 mole over 6.02 times 10 to the 23rd atoms, or molecules. And then we can do some calculations. So let's look at number 1. How many calcium atoms are in 0.250 moles of calcium? So if it was 1 mole, I could answer it. I would know there's 6.02 times 10 to the 23rd atoms in a mole, but I don't have 1 mole. I have 0.250 moles. So we're going to start with that, 0.250 moles. Now, next to it, we're going to have Avogadro's number. Is moles going to be on top or bottom, considering we need moles to cancel out? You're correct if you said moles needs to go on the bottom and then atoms goes on top. Looks like that. 0.250 moles of calcium times 6.02 times 10 to the 23rd atoms over 1 mole, because there's 6.02 times 10 to the 23rd atoms in a mole, per mole. Moles cancel and we get atoms, and the answer, if you do it right in your calculator, 1.51 times 10 to the 23rd calcium atoms. Let's remind ourselves how to do scientific numbers in a calculator because it's been a while. So with this calculator, it's a TI-30X. You go 6.02. Don't hit times. Use your exponent button, the EE or EXP button. Then just type in 23. You're good. Now, divided by 1 mole and hit equals. So let me try that again. I got to put in what we start with. 0.250 times 6.02 EE or EXP 23 divided by 1 mole. You really don't have to divide by 1, but I did anyway. Equals. And it says 1.505 times 10 to the 23, but how many sig figs do we have? We started with 3. Avogadro's number has 3, so 3. So we round it to 1.51 times 10 to the 23rd calcium atoms. All right, number 2. Calculate the moles if we have 3.75 times 10 to the 27th molecules of oxygen gas. So write down what you're given, 3.75 times 10 to the 27th molecules of oxygen gas. What is oxygen gas? O2, right? O2. It's a molecule of oxygen gas. It didn't say atoms, it said molecules. Oxygen's diatomic. Have no fear of ice cold beer. O for oxygen. It's O2. That's important. All right. Now this time, where will the molecules be? On top or bottom? I hope you said on bottom. So this time the mole's on top. And it looks like this. 3.75 times 10 to the 27th molecules times 1 mole divided by 6.02 times 10 to the 23rd molecules, and it equals 6,230 moles. Molecules canceled out. Let's punch that into our calculator. 3.75, exponent button, don't hit times, don't do times 10, it's exponent button. 27 times 1 divided by 6.02, exponent button, 23, equals 6,229.23588 is the answer, but how many sig figs do we have? Well, we started with 3, and 6.02 is 3, so 3. So 6,229 rounds to 6,230, not 623. You got to put a 0 there. 29 rounds to 30. There's a 0 there. All right, so that's how we calculate between atoms and moles or molecules and moles. We use Avogadro's number. Good job. Let's move on. Now we're going to go from moles to grams or grams to moles using the molar mass. Do you remember where we got our molar mass from? I hope you said periodic table. Yeah, the molar mass is the grams per mole. It's the grams per mole in the table. So get your periodic table out, get your calculator out. Number 1, how many grams is 1.667 moles of oxygen gas? Start with what you know. 1.667 moles O2. We just talked about oxygen as O2. Okay. We're trying to get to grams now. We have moles, so we're going to need a molar mass. We need the molar mass of oxygen. Well, let's find oxygen. Oxygen 16.00, but that's for 1. O2 is oxygen gas. That's 2 of them. So we need 2 times 16.00, which is 32.00 grams per mole. Okay, so 1.667 moles times, we got 32.00 grams per mole. Moles will cancel. Let's look at just the first one's answer here. Woo, that's fun. All right, there we go. Look at just the first one. 1.667 moles of oxygen. We got 32.00 grams in 1 mole, so grams over moles. Moles cancel, and we get 53.34 grams of oxygen. So again, all we're doing is adding up the molar mass and using it to convert between moles and grams or grams and moles, because it's a molar mass. All right, I want you to try numbers 2, 3, and 4 on your own. Seriously, hit pause, okay? Just hit pause. You got your periodic table, you got your calculator, you got your brain. Work your brain. Try these on your own. I'll be back in a minute. You didn't hit pause, did you? Well, I hope you did. I hope you did. Let me show you the answers. Here we go again. Whee! All right, number 2. 45 grams of silver. Silver is Ag, not AU, Ag, Ag. When we look up Ag in the periodic table, we see its molar mass is 107.87 grams in that mole. But this time, we needed grams on the bottom because we started with 45 grams. So we need grams to cancel out. So I put 1 mole over 107.87 grams. Grams cancel and we get 0.42 moles of Ag. Why 2 sig figs? Because we started with 2 sig figs in the number 45. Excellent. Number 3. How many grams is 0.0554 moles of water? We should all know water is H2O. Yeah, we know that. We got this. 0.0554 moles of H2O. Now we got to add up the molar mass of H2O. So 2 H's, which is 1.01 times 2, plus an O is 16.00. That is 18.02 grams per mole. Moles cancel. We get 0.998 grams of water. And number 4 was hard. So we had to put what we learned in the previous slide together with what we learned in this slide. Putting it together, making a bigger problem. 4.75 times 10 to the 16 atoms. We got to change that to moles before we can use a molar mass. Now, again, a mole contains 6.02 times 10 to the 23rd atoms. Atoms cancel, we got our moles. Now that we have moles, we can use molar mass. Molar mass of K is 39.10. Okay, 39.10 grams per mole. Now the moles cancel, and we got grams. And if you punch it in your calculator correctly, you get 3.09 times 10 to the minus 6 grams of potassium. That's a good problem. You need to punch that in your calculator and make sure you get the right answer. The exponent is a negative 6 there. 3.09 times 10 to the minus 6 grams of potassium. Okay, I hope you worked on those. And that's good enough for now. So we'll say bye for now. See you in the next video, GCC.